All right, so section 5.5 is talking about solving equations that have radicals or roots in them. But this first problem is just a review. So I just wanted to review it really quick on how to sketch a circle by hand. All right, so keep in mind the formula for finding the area of a circle, or I'm sorry, the equation of a circle, pardon me, said that wrong, is this, all right, where HK is your center and R is your radius. Okay, so if you're given something like this, first of all, you got to find what is the center point. Well, the center point here, so what would H be here? So if I look at this, these are both negative. Would you agree that H would be 1? So my center is going to be 1. Now let's look at this one. Now this one has a sign change. So what this means is K would have to be a -2 in order to make it a +2, right? Because you would have a minus, a -2. So what we're going to use here for this point, what K should be is a -2. So always keep in mind, it's always going to be the opposite really of what the sign is inside of there. And then our radius is 9, but that's R squared equals 9. So if R squared equals 9, to find what R is, we're going to square root both sides, and we're going to have R equals 3. Now, normally we put a plus or minus whenever we square root, because it could be a -3 times a -3, or a +3 times a +3. So normally when we square root, we would put a plus or minus on this. But the reason why we don't have to do that is because we can't have a radius of a negative distance. So it's always going to be positive. So we really don't have to worry about that. All right. So then all you have to do on this is sketch it. So we have a center point at 1/1 down 2. That's our center point. And we have a radius of 3. So just count 3 over from each of these. Mine won't look great. All right, so just trying to kind of get a decent looking circle. Looks like an ellipse, but anyway, that's how you can graph your circle. All right, and it's okay if your sketch looks as bad as mine. I'm good with that. All right, but this is kind of the work you need to show me. You guys show me what the center is, show me what the radius is. All right, so let's talk about solving equations with roots. So I'm just going to give you a couple examples here. So let's start with this first one. And this one's going to be, so whenever you have a root in an equation and you're going to solve for that root, your first thing that you need to do is isolate the radical. So you want to get the radical on one side by itself. So what that means, I'm just going to add x to both sides. So I can get this radical by itself. And I'm going to just write the variable first. I think that's a good thing to always get in the habit of. If you write 1 plus x, it's not incorrect, but then it's already in descending order, which is a good thing to write, how you should write your equations or your polynomials, okay? All right, so how do I undo a square root? Well, remember this square root means 1/2, right? It's the power over the root. Well, if I take a fraction times its reciprocal, which in this case would be times 2, all right, that then gives you an answer of 1. So that then gets rid of the radical. So if this were a cubed root, that would mean 1/3. So I would take this to the 3rd power. So it'd be like 1/3 times 3, and that would make it 1, and that's your goal. So because this is a square root, that means 1/2. I'm going to multiply it times 2. So let me show you off to the side what I'm talking about if you don't understand what I'm saying. So 11 minus x, right? It's the power to the root. So the power of that is 1, and the root is 2. So how do I get rid of this? How do I make this 1? Well, I just take that whole thing to the 2nd power. And when you take a power to a power, you multiply. That's your power rule for exponents. So 1/2 times 2 is 1. So that gives you 11 minus x to the 1 power. So if this is a cubed root, right, then it's going to be 1/3. So I would take it to the 3rd power. So that's all I'm doing right here, is taking it because it's square, a square root, taking it to the square. Now, what you do on one side, you always have to keep it balanced and do it to the other side. You always have to keep your equations balanced. That's what allows you to do the work. So from here, we have 11 minus x. right? Because these cancel each other out. We end up with 11 minus x. Now this is saying take x plus 1 times itself. That's what the squared means. Take this times itself. So we need to multiply those binomials through. So you can use FOIL, distribute, however you do that. So I'm just going to distribute. X times x is x squared. X times 1 is a plus 1x, and I don't have to show the 1. Okay, so I distributed the x. Now let's distribute the 1. 1 times x is 1x. 1 times 1 is 1. Now let's simplify that. These are like terms. 1x plus 1x is 2x. All right, so notice now we have the radical is gone, the square root's gone. So what we want to do is get everything on one side and set it equal to 0 so we can solve for x. So what I'm going to do here is I'm going to subtract 11. I'm going to do this in one step. I'm going to add x. Doing that all in one step. So this becomes 0, and we have an x squared plus 3x minus 10. Okay, so I'm going to bring this work up here, bring it up here to finish. So we're going to factor this out. So 0 is equal to, let's see, what multiplies to equal 10, negative 10, can I get 3? We're going to have a 5 and 2, we can get 3 there, and we need a positive 3. So then if I multiply it, that'd be a negative 10. Now set each of these equal to 0. So we have x equals a negative 5 and x equals 2. All right, now you got to take it back. You have to check. So you have to check this. So take this back to the original problem. So square root of 11 minus a negative 5. Careful with the negatives there. Minus a negative 5 equals 1. So this becomes 16. So this will be 11 plus 5, which is 16, plus 5. Okay, what is the square root of 16? 4. 4 times 4. All right, so this becomes 9 equals 1. Well, that is not true. So this is not a solution. That's why you have to check them. All right, and I'm not going to go through and check 2, but I will tell you when you do, this will be the answer. So this is going to be your solution. But you have to show the work, and I will look at that on your test, that you check to be sure that one answer is, maybe they'll both work, maybe they won't. Okay, so that's just something you have to figure out. All right, so let's look at the next problem. So we have another one. Again, these are off your study notes. So here, so let me move this up a little bit. All right, so again, now what's nice about this one is our radical is already isolated. So on this problem above here, when I had to add this x, I don't have to do that here because this is already isolated. It doesn't matter which side it's on. So all I want to do, it's a square root. So I'm just going to square it so I can get rid of that square root. But then again, you have to square this side. So this is saying take x plus 4 times x plus 4 equals, these cancel each other out. And we're kind of back to where we were up here, where we just have to solve, multiply it through, and solve for x. So distributing through, x squared plus 4x plus 4x plus 16. And let's get everything on one side. So I'm going to actually combine like terms first, 4x plus 4x. All right, so let's subtract x. I'm going to do it in one step, and we're going to subtract 6. Be sure you line it up correctly. So x squared plus 7x plus 10 equals 0. Now let's do what we did up here when we came up here and factored it. So let's factor. And this is a nice factorable problem. It's nice when this is 1. I can just split those x's. Multiplies equal 10, can add to get 7. So we're going to go with 5 and 2, positive 7, and multiply back to a positive 10. Set each of these equal to 0, like we did right here. This would be x equals a negative 5, and x equals a negative 2. So again, we're going to go through and check that. All right, so if we go through and check, let's just start with a negative 5. We're going to go back to the original. So the original was, let's see, negative 5 plus 4 equals radical negative 5 plus 6. All right, so what's happened here? So we have a negative 1 equals the square root of 1. What's the square root of 1? Well, it's 1 times 1. So that doesn't work. So that one does not work. Let's just try negative 2 to be sure. So negative 2 plus 4, you have to always try them both, equals negative 2 plus 6. So let's see what we're going to have here. So here we have 2 is equal to square root of 4. Well, the square root of 4 is 2. So that one works out. So that would be your solution. Whoops, sorry about that. That would be your solution. All right, one more problem here we need to do. I'm just going to go on the back here. So let's take a look at this one. This one is kind of an advanced one. This would be more of a challenge problem. All right. This would be more of a challenge problem. So again, you have to isolate the radical. So it doesn't matter which one you isolate, but what I'm going to do is I'm just going to add the square root of x plus 1 to both sides. So then we're isolating that radical right there. So we have radical 2x plus 3, 1 plus square root of x plus 1. All right, so now we have them isolated on each side. So what we want to do is, let's go ahead and we're going to get rid of this radical first. We've got to do it one at a time. So here we're going to square it, but then I have to square this whole thing together. Don't try and square the one and then square this individually. This, because it has an operation, has to be kept together. So this cancels out your roots. So we have a 2x plus 3. All right, so what we're taking here is 1 plus, and this really isn't that, it seems like it's a lot more difficult than it is, to be honest, but all right, so let's go ahead and distribute that through. So we'll leave our 2x plus 3. All right, so 1 times 1, 1 times the square root of x plus 1. All right, now we're going to take this times 1, so we're just going to have, and we're going to take this times this. What happens when you take a radical times a radical? It just gets rid of the radical. For example, let me just show you. If I take the square root of 3 times the square root of 3, square root of 9, well, the answer is 3, right? So if I take the square root of x times the square root of x, that's going to be the square root of x squared, which is x. So whenever you take a radical times itself, it just comes out to be whatever's under the radical. So that's the same thing here. When I take this times this, it's just going to be an x plus 1. So let's combine like terms. So 1 and 1 would be, let's go ahead and do our x first. Okay, plus we have 1 square root of x plus 1 plus 1 square root of x plus 1. So 2 square root of x plus 1s. And then we have a 1 and a 1, so we have a positive 2. So now we're back to where we kind of want to isolate that radical again. So we just kind of got to do that process again. Let's do this by itself. So let's go ahead first of all and subtract x, and then subtract 2. We'll start with that. Do it in one step. This becomes x, this becomes 1, and then we're left with 2 radical x plus 1. Now, if you're doing a multiplication here, one thing that's nice that you can do is I can go ahead and square this and keep that there. And it makes it a lot easier than, I could have divided by 2, but then I have this fraction I have to square, x plus 1 over 2, and that's a pain. So if I just keep it here and I square it, let's work that out. So this becomes an x plus 1 times x plus 1. All right, so 2 squared. Well, 2 squared is 4. And then this square gets rid of the root, so it's an x plus 1. So then I will have to distribute this 4 through. So let's go ahead and multiply here. So x squared plus 1x, okay, plus 1x plus 1, and distribute here 4x plus 4. Combine like terms here on the left side. 1x plus 1x is 2x. Now we're going to set it equal to 0 so we can solve it. So let's subtract 4x, do this again in one step. So we're left with x squared minus 2x minus 3 equals 0. Again, that's a pretty nice factorable problem. So let's factor that, split the x's, multiply to equal 3. Well, that's only 3 and 1. We need a negative 2 when we add them together. Now double check when I multiply that, I get this term. Set them equal to 0, so x is going to equal 3, and x is equal to a negative 1. So let's go back to check it in the beginning. So we're going to have 2 times 3 plus 3. I'm putting the 3 in. 3 plus 1 equals 1. So all I did is take this 3 and put it in for x here and x here. X here and x here is where I substituted that in for. That's the original problem. All right, so here we have 6 plus 3 is 9, so radical 9. 3 plus 1 is 4. So square root of 9 is 3. Square root of 4 is 2. That looks good. So that one checks out. So we know x minus 3 is a solution. Now let's try negative 1. So here we have 2 times a negative 1 plus 3 minus, and oh, let me rewrite that. Radical negative 1 plus 1 equals 1. So let's see what happens here. So this becomes a negative 2 plus 3 minus, this is just 0. Negative 1 plus 1 is 0. So the square root of 1 equals 1. So it looks like that one works as well. So that one checks out. So both of these are solutions. All right. Now on the study guide sheet, for those of you in 1400, we were going to do rational exponents, but that is something that we are not going, because we're short on class time. We lost some class time throughout this whole thing. So we are not going to worry about doing the rational exponents, solving equations with rational exponents. All right. The last thing I guess I probably should talk about, this is just a review. So if we're given this function, oh, that's to the third. Oh, that's to the third. Can you read that? Okay. And then to the 8th. So the question says, name the zeros and name the multiplicities. So first of all, the zeros are where if I set these equal to 0, 5 equals 0. If I just made this a 0 here, if I took 5 equals 0, that just cancels out, right? But if I take x minus 2 equals 0, then that's going to be x equals 2. If I take, don't really worry about the root, okay? So what is it that I can put in here to make that a 0? Well, that's going to be a negative 4. So negative 4, and then an x plus 1, we would have a negative 1. Those are the zeros. Now, these are the multiplicities, and those change your behavior in your graph. Like maybe it will flatten it out when it goes through the x-axis. I mean, it does different things. So that's why the powers are important. All right, so when I talk about a multiplicity, what I would probably say is something like there is a 0 at 2 with a multiplicity of whatever this power is, 3. That means it's like a root 3 times, 2, 2, 2, right? Because there's 3 of them. So that's what that means. So then I would say, well, I have a 0 at negative 4. If I set that equal to 0, at negative 4 with a multiplicity of whatever the power is, 8. So this one has a power of 1, so there's no multiplicity there. There's not multiples, so I don't have to write it as a multiplicity. So these are your 2 answers that it's looking for. And that's just a review. That's not something we have just done, but that's just a review. I think maybe you'll see a problem similar to that on a, could be on a final, something like that. So just be sure you understand that. All right, you guys, there's your section 5.5. I think that's all chapter 5 that we have. So we'll be start working on maybe the chapter 5 review when you finish these. I'll try and get that posted for you. All right. And I hope you have a great day. Take care.